Hello everyone, I'm Dhanashree, founder trustee of Canine Control and Care Trust, with my colleague Beena, presenting the behavior-centric animal birth control model implemented by us in the Thar Desert region of Pokhran, India. At Canine Control and Care, over the last decade, the core focus of our work is approaching dog population management programs with kindness, which results in a positive experience for the dog. We've sterilized over 100,000 dogs to date. Right from catching to sterilization, post-op and release, we ensure low-stress handling of the dogs. The end goal is not only to control the dog population, but to do so in a way that will decrease human-canine conflict. We work closely with a volunteer base of over 2,000 individuals who actively support our DPM program. This project explored whether predictable feeding and positive human interaction could reduce avoidance behavior in free-ranging dogs and make humane sterilization possible in an extremely difficult desert ecosystem. Before we get into the details, we'll briefly walk you through the structure of this presentation. We'll explain the context and need for intervention, the challenges faced in the field, our behavior-centric ABC model, and the operational outcomes observed during this project. This intervention was carried out across villages located near wildlife-sensitive grassland areas, which are important habitats for endangered species such as the Great Indian Bustard and the Chinkara. The objective was to implement predictable feeding, positive human interaction, and community participation to reduce avoidance behavior in free-ranging dogs and make humane animal birth control feasible. The central question behind this work was simple. Can trust-based behavioral conditioning improve the safety, ease of implementation, and welfare outcomes of dog population management in difficult field conditions? The project was conducted across 5 villages in the Thar Desert. Initially, using the site-re-site method, we estimated about 600 free-ranging dogs. However, once regular feeding began, many previously hidden or highly avoided dogs started appearing consistently, and the observed population increased to nearly 1,000 dogs. This itself was an important learning for us. Traditional estimation methods may undercount highly avoided populations in extreme terrains. We also found that nearly 95% of the dogs that were seen during feeding had body condition scores between 1 and 3, indicating severe food scarcity and difficult survival conditions. The Thar Desert presented unique operational challenges for DPM implementation. The villages are spread across vast open desert landscapes, and the free-ranging dogs exhibit extremely strong avoidance behavior. Dogs did not seem at all familiar with interaction with humans, as culturally people in those villages do not keep dogs as pets. Dogs stayed at a distance from people and ran away if approached. Conventional ABC programs in India typically depend on force-based capture methods like butterfly nets and restraint tools. In this environment, those methods would be ineffective as dogs have an open desert area to run away at speeds which would make them impossible to catch. Additionally, this region is a very critical military zone, so our staff movement was restricted. Our central hypothesis was simple. If dogs experience predictable feeding and repeated positive human interaction, their avoidance behavior would reduce over time, allowing low-stress capture without force. Instead of treating the dog population management challenge as only a surgical problem, we approached it as a behavioral conditioning problem. The focus shifted from how do we catch the dogs to how do we reduce fear and increase trust. The intervention was implemented in 4 phases. Phase 1 involved preconditioning through twice daily milk feeding and auditory cues. Milk was used because the local Vishnoi community prohibits meat, eggs, and commercial dog foods due to religious and cultural beliefs. The goal was to establish temporal and spatial predictability. The dogs began associating specific sounds, timings, and locations with food and non-threatening human interaction. Phase 2 involved gentle handling without the use of butterfly nets, nooses, or force-based restraint methods. Phase 3 involved low-stress captures with photographic documentation of pickup sites, followed by surgery and vaccinations over a 5-day capture-to-release cycle as per the Indian Animal Birth Control Rules 2023. The final phase was of releasing dogs to the same location, followed by continued feeding and behavioral monitoring.
A major reason this project succeeded was because it was culturally aligned. Local villagers were trained as feeders, though there was a lot of hesitation to work with dogs. But their love for wildlife encouraged a few of them to become part of the feeding program, which ensured consistency and community ownership of the process. The Bishnoi community has a strong tradition of coexistence with wildlife and animals. Working with their cultural framework was essential. This was not an externally imposed intervention. The community itself became part of the behavior conditioning ecosystem. One of the most important findings was the behavioral transformation we observed. At the start of the intervention, approachability was close to zero. Dogs would immediately flee upon human approach. The dogs there survived on cow carcasses when available and other scraps. We used milk, which turned out to be a high value treat for them. Within approximately 3 weeks of consistent feeding and positive interactions, approachability up to 2 feet from the feeder without flight response increased to nearly 80%. Dogs began waiting calmly near the feeding points and showed dramatically reduced fear responses. This demonstrated that predictable food access and non-threatening interactions can rapidly alter avoidance behavior even in extremely difficult environments. Over 8 months, 850 free-ranging dogs were sterilized and vaccinated. Nearly half are female dogs, which is important from a population control perspective. To manage extreme heat conditions, surgeries were conducted around 4 a.m. and only a few dogs were sterilized each day. This resulted in surgical complication rates below 1% with zero post-surgical mortality. Our entire operational cost per dog was approximately $50, which included capture, transport, kenneling, surgery, medicines, vaccines, feeding, and staff costs. Importantly, throughout the entire project, there was not a single dog bite incident involving the CCC team or local feeders. This supports the safety advantages of trust-based engagement over coercive capture methods. After predictable feeding and repeated positive interactions, many free-ranging dogs began staying closer to village feeding points. This appeared to reduce roaming toward wildlife-sensitive grassland areas during the project period. We are presenting this carefully as a field observation, not as a final ecological conclusion, because we could not use GPS collar tracking or a controlled movement study due to restrictions imposed being in a highly sensitive military zone. The feeding was also tapered gradually after release because the objective was not a long-term dependency. It was used as a short-term behavioral conditioning tool to improve approachability, reduce stress, and make humane DPM more feasible. The key insight is that behavior-centric ABC model can potentially improve not only capture efficiency, but also the predictability of dog movement in sensitive landscapes. This now needs stronger monitoring through repeatable field indicators.
The main learning from this field intervention is that behavior matters in free-ranging dog population management. In difficult landscapes like the Thar Desert, DPM is not only a surgical program, it also depends on whether dogs can be approached, handled, and released safely. This project showed that predictable feeding, positive human interaction, and community participation can reduce avoidance behavior and make humane capture more feasible. A second important takeaway is that local culture must be built into program design. In this case, the protocol worked because it respected local community values while still achieving DPM and vaccination objectives. Finally, for wildlife-sensitive landscapes, dog population management should combine welfare, public safety, vaccination, sterilization, and monitoring. The CCC Pokhran model gives us a practical field example, but future work should strengthen the evidence through repeatable indicators and long-term tracking. Thank you so much for listening. Through this presentation, we have tried to share the CCC Pokhran field experience, not as a final or perfect model, but as a practical case study in adapting dog population management to a difficult ecological and community setting. We are deeply grateful to the Bombay Natural History Society, local communities, and wildlife authorities who all supported this project. We plan to return to sterilize the juvenile dog population that was not addressed in the first phase. We welcome questions, feedback, and suggestions from the ICAM community, especially on how this model can be strengthened and replicated in other wildlife sensitive or hard to access regions. Thank you. We look forward to the discussion.